Where did all the rocks go? When you look around and you see our landscape, it doesn't look like the landscape that we know must have been here some time ago when this area was full of volcanoes and had huge amounts of lava being spewed out everywhere. So if we had all these big volcanoes and large lots of lava fields, the question is, where did all the rocks go? And the answer is all around us. Let's take a look. Here are the 12 Apostles, well known in Australia. Been longing to see them most of my life. Now this is back in early 2000, and this is more recently. As you can see, the 12 Apostles are no longer 12 anymore, and soon there won't be any left, because water and wind have been slowly breaking down the 12 Apostles and undermining their structure. Because you see, the 12 Apostles used to be part of the edge of our coastline, and over time wind and water has actually eaten away the land between them and the coast, leaving them essentially on their own. But exposed and on their own, they only last a short time. Here is a rock called Old Man's Rock. It actually no longer exists. It was a very famous rock formation, which a lot of people thought looked like an old man, and this is what it looks like today. No longer Old Man's Rock. Here is Mount St. Helens. This is a well-known volcano that was thought to be completely dormant until it had a volcanic explosion not too long ago, which took off the top of the volcano, took away all of the forest in the surrounding areas, and this is St. Helens today. Here is Uluru, also known as Ayers Rock, and as you can see here, what we often think of as a solid, strong rock is actually slowly being eaten away or eroded along the sides here. So in the future, we're going to see a breakdown of this rock. This is in Bolivia. And as you can see, what was once a very large piece of rock, because they don't naturally form with a tiny little bottom like that, has been eroded away or broken down until this tiny little bottom has been left and a large rock area on top. Over time, this of course will weaken to a point where the entire structure will collapse. And finally, one of man's masterpieces, this beautiful statue. Well, beautiful once, but not anymore. As you can see, this statue does not look like it was originally sculpted, because different types of elements and chemicals have eaten away at the rock that forms this statue. And here's another formation, although natural this time. Rocks don't naturally form with holes in them like that. This rock has been eaten away by various forces, leaving a large hole in it, and as you can see, there's more erosion happening along the sides of the rock here as it degrades. And lastly, this is a rock from a really, really cold area, which is your first hint. And you can see that they've got these stress fractures that are very straight, really, going through the rock. And we're actually going to look at what causes this sort of rock breakdown now. So essentially, the rocks that were around us have been broken down into smaller and smaller pieces. You see, weathering is the breaking down of rocks, and it happens constantly all around us. There are two types of weathering: physical and mechanical weathering, and chemical weathering. Now, it's pretty easy to understand the differences between these two when you go into it a little bit. Physical or mechanical weathering is weathering that doesn't involve a chemical reaction. The first one that happens constantly is temperature changes. When you have something get hot or cold, it causes things to expand and contract. Now, if you do that to solid rock, then you're going to find that enough expanding and contracting of something that's extremely solid like that will cause it to crack in its weakest places. Now, as soon as things start to crack, other things get in. So the first one is ice. We don't have so much of this in Australia except in our coldest areas, but ice, when water gets in those cracks that were caused by expansion and contraction, if it freezes, ice expands itself. So if you've got ice in a little crack, or water in a little crack, and it freezes and expands and gets bigger, it actually goes into that crack and splits it apart. Here's a picture. So if you've got water seeping into an already formed crack, when it freezes, it will expand its volume. And because it expands, it will push this rock apart further and end up cracking it over time. The next thing is salts. Salts, just like ice water, will get into the cracks. As the water evaporates, it will leave the crystals of the salts behind, and they will expand and push open the cracks in the rocks. Wind is another factor because it basically acts like sandpaper. When wind blows, it blows small particles along with it, and they act like sandpaper across the rocks and will slowly wear them down. And the last thing is living things, which cause an awful lot of damage. We move around, we bump into things, we wear things down. Anyone who's seen a cattle paddock knows how quickly they can etch in tracks into the mountainside. And over time, that constant wear and tear and moving causes things to break apart. Now, chemical weathering involves chemical reactions, so that's actually where you take the rock and you cause a chemical reaction, which means the atoms rearrange and make something new that wasn't there before. So gases. Gases are all around us, and most people think that they don't do too much except allow us to breathe, but gases are chemicals in a gaseous form, just not liquid or solid. And oxygen and carbon dioxide tend to react with an awful lot of things. You'll know if you leave bare metal out in the weather that it will start to rust, and that's because of a reaction with the oxygen gas in the atmosphere. Well, rusting occurs on rocks too. They will actually react with the gases and form different type of oxides. In other words, they've reacted with the oxygen, and you'll see them going all brown and dull, and that new chemical that they'd formed is actually weaker than the original chemical that the rock was made of before, so it's easily eroded away. Acid rain, we know about this now because all of the pollutants we have in our atmosphere are putting an awful lot of gaseous chemicals into our atmosphere that when they dissolve into the water in the clouds, they form acid, and literally it eats away a rock. Here is a picture of acid wear and tear, that one. So this one here has actually been caused because it's in an area in Europe where there's a lot of acid rain, and the acid rain actually is destroying an awful lot of the precious monuments that we have. Water. Water doesn't seem like something that could do a lot of damage, but it actually causes a huge amount of change in our environment. Water likes to dissolve things, and as we know from our mineral cracks, that the minerals that rocks are made from can easily be dissolved in water, and then you evaporate them off and make crystals. Well, the opposite can occur. You run water over a rock and it will dissolve the crystal minerals that are making up that rock itself and wash them away. Last but not least, living things again. Yes, we do tend to break things down quite well, and if we're not moving and wearing and tearing things down, we're releasing acidic compounds like, well, in the case of animals, urine, or in the case of other organisms, other acidic compounds, and they break down the rock to release the nutrients. It's quite deliberate because rock is made out of chemicals, minerals, many of which organisms need to actually ingest to survive. So here's a picture. This lichen here lives on this rock. It releases little organic enzymes that break down the rock underneath to release the minerals that are underneath it so it can absorb them and essentially eat the rock a bit. So that's why it likes growing on that rock. It actually eats part of the rock. So as it does that, it's slowly breaking down and weakening the rock, which will eventually crumble underneath it. Okay, so over time, all of this breaking down rock ends up with lots of pieces of broken down rock, which we call sediment. Now, because this breaking down of rock occurs in conjunction with living things living on the surface, as we die as well, we end up getting buried in that broken down rock. And a mixture of broken down rock and dead organic matter, which is living things, makes soil. So essentially, all of the original mountains that would have been around here, a lot of them have been weathered and broken down, and what you see around you is the soil remnants of what was once here. Soil is the final product of breaking down of those original mountains, and the living things having added wastes and dead organic matter into that broken down rock to create soil. And what we see around us is the leftover of that entire process. But as we know in Australia, soil doesn't often stay where it's supposed to. It often moves. So, what has happened to all that broken down rock? Not all of it has stayed. A lot of it tends to move away. This is a massive sandstorm, okay, over in Iraq, and as you can see, this would have millions of tons of sand being carried along with it. So the sand, which is broken down rock again, doesn't stay where it was broken down. It's often moved to different places, and we know this. We've had lots of floods in Australia recently. An awful lot of our topsoil has been either washed away or blown away by different types of storms and weather movements. Here's another example. Coastal erosion is a big one. This is soil which used to be rock and is now soil because it's been broken down rock mixed with organic matter. And as you have water interacting with soil, you're going to have some of it washed away with the water. So wind and water are our main instigators of what we call erosion. So erosion is the removal of broken down rock and the organic matter that's stuck within it, i.e. soil. And there are three main agents of erosion: water, wind, and ice. Now we often don't realize that ice can do this, but on large scales in a lot of the colder climates there are frozen rivers of ice. We call them glaciers, and as they very slowly move down the landscape, because a frozen river doesn't move fast, it actually rips and grabs the soil beneath it and pulls it along down with it. So ice is actually quite a big agent of erosion in various parts of the world. Okay, so you've moved all this rock and broken down rock, but where has it gone? Because it doesn't just disappear. So the question is now, when the broken down rock is moved away, where does it go? Well, the fact is, once it gets settled into a new area, it ends up making new rock. Here's an example. This used to be part of a sand dune. And as you can see, all these lines here, we call this cross-beading. And believe it or not, this is evidence of the sand slowly building up over time in a dune and leaving different layers of sand over time to create this rock formation. Now, as you get enough on top of it, enough layers, it will actually start cementing together through different processes and forming its own new type of rock called sandstone. Here's another example of this layering effect. This is the Canyonlands, Schaefer Canyon. Now I've blown this up a little bit here. A lot of you, if you look around, you'll realize that when you see fresh cut rock faces, there are very distinctive layers. And each of these layers is different layers of deposition going in on top of it. Okay, so a lot of these finer layers here would actually be different types of sediments laid down over time, and then as other stuff gets dropped on top of them, they actually get compacted together and cement together to form rock, a new type of rock. And it's quite easy to figure out, I guess, that the lower down you go, the older the sediment. The stuff that was put down last will be on top, and the stuff that was put down first will be on the bottom. To end all of this, once you've broken down rock, moved it away to a different place, the last thing that it does is it forms sediments in layers and then gets compacted together to make new rock. So we call these two stages sedimentation, broken down rock forming layers, and compaction, where the layers build up and the sediments are pushed together and they lock together and cement together and form a new type of rock. And we call this type of rock sedimentary rock because it's made out of sediments. Now, this type of rock can give us many clues to what has happened in the past, because as sediments form, other things get trapped in the rock. So we're going to be looking at next the different types of sedimentary rocks, the processes that form them, and the hidden treasures that we find in these sedimentary rocks, which we call fossils.